Okay, so today what I wanted to go over is a lesson called Lesson 12.1, Day 2, so I'll title the lesson first. Always want to put, what do you always want to put on? Yeah, you always want to put on the date because you want to be able to know whenever this happened, right? Okay, so let's talk about this. So today we're going to talk about limits that go to infinity and beyond, yes. Those light years would be proud. So today we're going to talk about limits that go to infinity. Okay, so if you recall, we actually saw a limit that went to infinity. Remember the limit x as it goes to 0 of 1 over x, right? Of 1 over x. Now, we're not going to do the graph of the table thing, right? Let's just look at a picture real quick to remember what happened. So, here's the picture. Function looks like this. Right? Function looks like that. Now, notice it's x as it gets closer to 0, right? So, as this function gets closer and closer to 0, from the left side, where is the function going to? Negative infinity, right? The function is shooting downward to negative infinity, right? But recall that when the function approaches from the right side, where is the function going to? There. Positive infinity. So, here the limit as x approaches 0 from the left. Remember the negative means from the left side of 1 over x is equal to negative infinity. And the limit as x approaches 0 from the right side of 1 over x goes to positive infinity, right? We all remember that. Now, we talked about this stuff. What happens when a limit doesn't approach the same thing from two sides? What does that mean? Undefined. It's undefined or what? The limit doesn't exist, right? Like in Mean Girls, right? So this limit does not exist. That's what Katie was talking about, right? The limit that she saw, when she did it from both sides, the limit did not approach the same thing. So in that case, the limit did not exist, right? Because negative infinity is not the same thing as positive infinity. Now, let's talk about that because I want to clarify something. I'm not saying limits can't go to infinity, right? That's not what that statement's saying. It's not saying that a limit, if it goes to infinity, is undefined, right? I want to clarify that. It's not that if a limit goes to infinity, it's undefined. What I'm saying is that if the two limits of where they're going don't match on both sides, then they're not defined. It is, however, possible for a limit to go to infinity. Okay? So let's look at an example where that happens today. So let's look at this example. Let's say we have a limit as x approaches 0 of generally the same function, except I'm going to change one small thing, and that is I'm going to square the x in the denominator. I'm going to square the x in the denominator. Okay? And so, how do I estimate this limit? How did I always do that? I'm going to do what? Let's do a table or a chart, right? So let's do that. So I'm drawing this table here. Draw this table. X and f of x here. In the middle, what do I want to put as my x? 0, because I'm approaching 0. I don't know what that middle f of x term is. Okay. So, let's do the same thing we did earlier. So, someone give me a number to the left of 0. That's very close to 0.
-0.001.
Yeah, negative 0.001. So that's really close, right? So we're going to put it right next to it. Let's go a little further out so we can kind of see the pattern. So like, what would be the number out here?
Negative 0.1.
0.1, right? Negative 0.1 specifically. Then if I want to pick the next one, 0.1, right? Good. All right. So let's see what happens here. Well, when I plug these values in, I get 100, 10,000, and 1 million. So as you can see, this gets really large really quickly, specifically because I'm squaring the term, right? When you square something, it tends to get very large very quickly, right? Now, so as x approaches 0 from the left side, as x approaches 0 from the left, what's happening to f of x? Where is f of x going? To infinity. Why is it going to infinity, Denise? Because it just keeps what? Yeah, it just keeps getting larger and larger, right? It doesn't really look like it's wanting to kind of converge or like get to any destination. It just looks like it keeps growing and growing and growing forever, right? So, it looks like when x approaches 0 from the left side, f of x shoots off to infinity. Let's see what happens on the right side. So, input the same values here, except positive. So I'm inputting the same values but positive. Is that really going to change anything? No. Why won't it change anything, Jose? Do you see why? Because what happens when I plug in negatives in here and I square them? Yeah, the negatives become positive, right? So if I input a positive, it really shouldn't change anything, right? The number should still be the same. So this is also going to be 100, 10,000, and 1 million. So, as x approaches 0, f of x is approaching what? It's also approaching, ooh, I did that backwards, didn't I? Sorry, that's 100. That stays the same. You just got to add a few extra zeros here. So let's see. There we go. All right, that fixes it. Okay. So it looks like no matter what way you look at it, or no matter what way you approach it, where is this function, where does the f of x approach? Not 0, the x approaches 0, but what approaches, f of x approaches? Positive infinity, exactly. So, is this approaching positive infinity from both ways? Yes, it is, actually. So it is the case that the limit as x approaches 0, how would I indicate on this limit that I'm approaching from the left side?
Negative.
A negative where? To the right, to the right top, right? You want to put it here. Don't put it in the front, because that means you have negative 0, which doesn't make sense in many ways, right? It's after the number. 1 over x squared is infinity. And the limit as x approaches 0, except because we're approaching from the right, we put what after the 0? Positive. That will be infinity, right? And so if it's approaching, if this limit approaches the same thing from both sides, if you get the same thing when you approach 0 from both sides, that means that this limit must be what? Infinity. Exactly. So again, that's my point, is that in this example, the one at the top that we did earlier this week, it was the case that when I plugged in the two, I got a negative infinity on one side and a positive infinity on the other, right? So that's why this limit didn't exist. But in this case, and let me draw this out for you so you can kind of see what this looks like. This function would look more like this. So that as I approach 0 from both sides, both sides of the limit shoot off to positive infinity. Thus, we could say the limit of this function as we approach 0 is positive infinity. So infinity is a valid solution. It is possible to get infinity as an answer, because that's where this is going to. It's shooting off to infinity. It's just getting bigger and bigger. All right. So any questions about this concept? Questions at all? All right. Go ahead and try. Let's go ahead and try an example. So try it. Go ahead and look for the limit as x approaches 4 of 1 over x minus 4 squared. Go ahead and try that one out. See if you can figure out where does that approach as you get closer to. Go ahead and give you let's see. Take about 4 minutes. So go ahead and take 4 minutes.
And then we did a chart.
So it could be a big clue, right? That's but it could also be enough to one power, or if it's yeah, what I spend really not like right now, you just got there.
Do you think I just paid $50 for Bungie? Maybe you're wrong. I mean, you should be used to being wrong.
I mean, you mean to like change the order. You could, but then you kind of lose the nice thing of seeing that
I'm gonna ask what the
it would still work, you would get the values, but then kind of
you know what they're totally. See, what I should be okay. Like I'm gonna have
yeah. So basically, like if you put one, like say you put like 0.3999 3.9, this number would go reproduce, but then it wouldn't make no sense. You're like, well, how is that going to go smaller than this? Yeah, you could do that. You would, so like right here, for instance, you would get an even larger number, and that would even further kind of say, oh, what is it?
I will give him my ticket. I was like, I will give him my ticket. I was like, what was that?
19, let's say it was like 9,999. That's clearly going to 2,000, right? But if you don't see a pattern like that, it's just 9,000, 10,000, 11,000. If it's just a pattern, right, you don't really see it going. Then you can say, oh, that's going to 2,000. That makes sense. Thank you.
Oh, you don't put zero in here?
No, I would, but I just don't know.
No. So in the middle, what did it make?
I don't know, man. I still don't know. I was like, okay, yeah. 1 minute. Oh.
What you do is you get your So there should be 1 over 3.9 minus
What?
Okay, let's take one more minute. I want to go around and see where everybody is, just so I can know we're ready to move on.
You got the right idea. Can't turn on the
All right, so let's go through. Let's go through this example real quick. So if people still seem a little bit confused, that's okay. It's a new concept. So, what happens here? Well, again, you want to make a table, put your 4 in the middle, and as x approaches, so on the left side you want to pick some numbers that get really close to 4, so 3.9, 3.99, 3.999, and that's going to be it actually gets large. It gets large really fast, right? By the time you get to 0.399, it actually gets to 1 million. And so that looks like that f of x is approaching what? That f of x is approaching what? Infinity. It's getting to infinity. As x approaches 4 from the right, so we pick 4.1, 4.01, 4.001. Pretty much does the same thing on the right as it did on the left, also approaches infinity. So what is this limit approaching overall? Positive infinity, right? Again, this limit is also, as in the example, is approaching positive infinity. Why don't we say it doesn't exist, Hector? What's the difference between like this and then the example we did like earlier that had an infinity? Like, why does this have an answer, but that one does not exist? No.
This one has the answer because both sides are approaching the same or integer.
Exactly. Not the same integer, they're just approaching the same thing, right? They're both approaching infinity. Anthony, you have a question? Yeah, well, that's kind of an interesting thought, right? Will there be a point to where if it goes to infinity, will they meet at the same point, right? That's higher. That's like a professor question. Sorry, I failed, guys. That was one. That's actually an interesting concept. Like, at what point does something become like shoot off to infinity, and what point does it just approach? Does it just approach infinity, or is there some like point where they're both touching and they're the same value? Yeah, that's an interesting question, right? And that's actually something people still struggle with. Like, what is the concept of infinity, right? What does it mean for something to go to infinity, right? Because as humans, we live for about how long? Like 80. Yeah. So none of us have a concept of what it's like to live forever, right? None of us get the concept of infinity because we just can't conceive of it. So it's a very interesting question. What is infinity, right? What does it mean for something to go off forever? Even though things like the universe is infinite, well, what does that mean for the universe to be infinite? So if I just drove out, like, I would never get anywhere. Anyway. All right. Let's do, let me see. I want to move on. Yes. Yeah, let's go ahead and move on. So let's talk about estimating limits at infinity. Let's talk about estimating limits at infinity. Let's talk about this. So, notice I didn't write limits at infinity, I'm saying estimating limits at infinity, right? So, what am I doing here? Well, this is talking about a limit that looks like this. So we'll see our old friend, the limit of 1 over x. But rather than x approaching 0, I'm not going to have x approach any number in particular. I'm actually going to have x approach infinity. What happens when the x value actually gets closer and closer to infinity, right? In this case, it's 0. I'll leave that as the cliffhanger. Why is it 0? You know? All right. So, here's, when you see a limit like this, here's the formal mathematical language. Here's what it's asking. Here's what the question is asking, saying, what is the limit when x approaches infinity? Right? That's what mathematically it's asking. You might see this on a calculus test or a pre-cal test, right? What is the limit when x approaches infinity, right? Now, of course, being the fact that we're just learning these concepts, we want to relate it to us and make it more of a question that maybe is easier to digest. So this is how you should interpret it. Should interpret this type of question. Does that go a question mark? How you should interpret it? Yeah, I guess the question, huh? So how should you interpret it? Yeah, it should be, yeah. Okay, how should you interpret it? What question you should ask yourself when you see x approaches infinity is, what number does the function get close to when x gets really big? Right? So that's essentially what it's saying, is when the limit of x approaches infinity, you're just asking the question, hey, if I just went on and on and on forever, if I just made x like 1 million, 1 billion, 1 zillion, that's not really a number, but if I just took it out that far, what would f of x come out to be? Would it be infinity? Or would it be, maybe it starts actually, the function actually itself is approaching a value, right? So, let's see what happens. So, let's actually look at this one. Let's look at this function that we did, 1 over x. So, if we're estimating this, what am I going to tell you to do? Table. I'm drawing a table. Now, everyone really pay attention closely, because in this case, I'm going to be drawing this table slightly differently than I've drawn it before, right? So, I'm going to draw the table as this. Everybody's like, oh, thank God. I am too, don't worry. She's actually really nice, by the way. I'm recording this. I shouldn't be talking about this. Okay. So, let's think about this for a second. Am I approaching something like am I coming from the left and right? No, I'm not meeting a friend in the middle this time, am I? I'm not saying, hey friend, you approach that side of the function from the right, I'm going to drive from the left, let's see if we meet up, right? That's not what's happening. Here what's happening, yeah, maybe my friend is just taking off on the function, and I have to shoot off right after him, right? So, the values are only going to get, we only want to go in what? One direction towards infinity and beyond, right? Like Buzz Lightyear said. So, rather than going in the middle and then kind of meeting up in the middle, we're just going to shoot off to the right, okay? So we're just going to say 10. Split this up into, let me do this first. Split this up into 5 different boxes. 100, 1,000, 10,000, and 100,000. Okay? So we split this up into 5 segments. Now, does everyone understand, like, for instance, Esmeralda, why would I have just, why am I going up like that? Because I'm doing what? Yeah, I want to see what happens when x gets big, right? I'm just going off, getting bigger and bigger. Thank you. So x approaches infinity. X approaches infinity. So when I plug these in, I'm just going to plug 1 over whatever value that is. You might actually be able to tell what it is. So 1 over 10 is just what? Does anyone know? 0.1, right? 0.01, right? 1 over 100 is 0.01. Good mental math there. What about 1 over 1,000? You get it. Yep, y'all got the pattern here. Okay. Hey, check that out. That's interesting. When x approaches infinity, or when the values of this function, when x get larger and larger, what's happening? It's getting smaller. The entire function is getting smaller and smaller. And as Jose just said over there, f of x looks like that it's approaching 0. Right? F of x approaches 0. Thus we say that the limit as x goes to infinity of 1 over x is equal to 0. Now, Mr. Schumacher sent me a very interesting study yesterday. I don't normally read his emails, but so what the study? Because you remember the algebra study they were doing. What they found was that students that understood both the procedural and the conceptual knowledge of math were able to do better on tests. Now, what do those two things mean, procedural versus conceptual? What does procedural mean?
Why we do it.
Steps, right? They just say, here's some steps, here's this table, input these numbers, and you got the answer, right? What does conceptual mean? Yeah, why would I do that? Why would I make a table, right? So let's practice some conceptual knowledge here. Why is it the case when x gets bigger, should I have thought, yeah, this function's probably going to go to 0? Because it's over 1. What is it? Yeah, when I have 1 over a larger and larger and larger thing, what is that going to get? Is it going to get bigger and bigger or smaller and smaller? Smaller, right? Because I'm taking 1 over a really large number. And 1 over, say, like, a billion is essentially what? It's really tiny, right? And so as x gets bigger and bigger, as x approaches infinity, we should expect that this function should go to 0. And if we look at the picture of this function, right, we look at the picture of this function, as x approaches 0, f of x approaches, f of x, infinity, approaches 0. Right? So as x gets larger, we can just see it in the picture, right? As x gets larger and larger, it's getting closer and closer and closer to that x-axis. All right. Any questions? Okay. Let's try one example and then we'll be done. Good. No, we're doing 3 examples now. So, let's take the limit as x approaches, negative infinity, of negative 3x over x squared plus 2. Now, let's change, now before you dive into this, let's talk about this. Whereas before, we were asking the question, what happens when x gets really small? What's the question, or really big? What's the question we want to ask here when x gets really what? Small, because we're going to negative infinity. So ask the question, what happens when x is really small? So go ahead, make the table or plot it on your graphing calculator if you think that would help you answer the question. Take about 4 minutes to do that. So how do you change the table, right? Before we did 10, 100, 1,000, 10,000. How do you think this is going to change things? Yeah, it's going to be negative. What's your one? You.
That's gross, dude. Come on. That's stress. That word
I love you, Melody.
that's not
Anesthesia.
It's like,
That's not what
Yeah, I know.
That's like, how do you put this here, Maybe it's right here. No, but it didn't look. Wait. Whoever makes down first. That was funny I'm sorry.
so funny because I'll just do ridiculous things up here during work time, like say weird things like aliens exist, and I have a mom that's an alien. Have you heard that study that just came out? That apparently there is about a 1 in a billion chance. So as we know, what does that mean? It's about what? Close, it's really small, close to 0, right? That there's life that exists on other planets, right? It's about a 1 in a billion shot, right? Because if you think about it, the planet has to have an atmosphere. It has to be close enough to the sun to where it receives its worth of an energy, but not too close to where what? It just get like incinerated, right? There's also a lot of other stuff that has to go on, like the CO2 levels of the planet can't be too big, or else you got a Venus greenhouse gas situation going on. Go ahead. Yeah. I think who's next? That's here in the yeah. But if we look at the sky, just in our own galaxy in the Milky Way, there's what, like billions and billions of stars, right? That have billions of planets. So it has to be the case, even if the chance is really, really small, right? Like 1 over a billion. If there's that many planets, there just couldn't be just 1 or 2, right? So anyway, so let's look at this one. So as we can see, as x approaches negative infinity. So everyone see what I did here? See what I did here? Negative 10, negative 100, negative 1,000, right? I'm approaching negative infinity. The numbers are not getting bigger. X is getting what? Smaller. X is actually getting smaller in this case. And when x gets smaller and smaller and smaller and smaller, What's happening to f of x? Where is that getting closer to? It's getting closer to 2. Right? It's getting closer to 2. Now, again, I'm all about intuition in this class. Why might it be getting, let's look at this function. Why might it be getting closer and closer to 2? The y-intercept's 2, okay, good. Go a little further. Why would the limit to infinity make it 2? What's going to happen to this negative x cubed term as x gets smaller and smaller? Or as x approaches, ooh, did I approach negative infinity? No, it actually should be the same answer. No, it is the same answer. So this is approaching negative infinity, right? As the x gets smaller and smaller, right? What's the x doing? It's getting closer to 0, right? It doesn't matter. Why does it matter that these are negative? Because what? Because it's squared, right? You're squaring this. So it's still negative 3 over a really, really big number, right? And so when it's negative 3 over an increasingly big number, what happens to that number? It just keeps going to what? 0. So this number matters less and less and less and less and less in this function as x gets larger and larger, and you're only left with what? You're only left with a 2. So that's why this function, when you get closer and closer to 2, when you get bigger and bigger, actually approaches 2. And if we look at a graph of what this function looks like, if we look at a graph of what this function looks like, we will see a picture that looks like this. And in fact, both positive, so as you go shoot off that way, and this way, we see this function get closer and closer to the line y equals negative 2. Thus indicating that in both directions that x goes to positive infinity and negative infinity, we should be seeing this approach 2. Again, for the reason that Denise mentioned that, or that I kind of helped her with too, though. that first term basically goes away, and then you're only left with the 2 left over. Okay? Okay, kids. All right. So, all right. So here's what I'm going to do. Okay. Has everyone got this down? Want to turn for the most part? Here's what I'm going to do. So, you do have a homework assignment. Now, here's going to be my thing. So, next Friday will be another week of lessons. And then the Monday after that, we're going to have our unit test. Okay? Now, again, like I mentioned, it's really important if you miss a lesson, grab a packet, watch the video online, because like I said, there's no time to teach a class again. Okay? Point 2. I'm going to make every homework from here on out. So this homework will be due on the 13th, which is Friday, right? Are we not going to be here that day? What's going to be that day?
Prom.
Ah, it's going to be prom, isn't it? All right, we'll get in Thursday.
Oh my God.
Okay. Monday? Okay. Okay. That's the final decision. So the day of the test, that Monday, right? That Monday, if you're a senior, we can talk about if you want to schedule. Again, we don't have a lot of time to do that. Please pay attention to it. Just a few more minutes. Or just a minute or two. What's up?
Wait, so all the homeworks are due next Monday?
Yeah, I'm going to do that. It's going to get too crazy if I try to assign a day we don't have class. Let's just make it due that day, right? So everything from here on out will be due that Monday. I don't care when you do it. Again, the lectures will be online. So it's going to be more of a, you either watch the lecture, come to tutorials. I just want that homework by that day. Are we clear on that? All right.
What about the homework you gave us?
Well, then you better get your homework in. What's that?
The homework you gave us?
Yeah, the homework that I gave you for this week, that's still due tomorrow. Because it's only one piece of homework. Huh? One sheet. All right. Huh? Actually, let me show that to y'all right now. How about that?